Welcome to the final installment of Chapter 2, L'Hopital's Rule. We have one more example of indeterminate forms of types, one of these three, and then we'll recap the method, and then we'll call it quits for L'Hopital, and we'll start Chapter 3 for the next video. All right, so I want to compute the limit of 1 minus 1 over x to the x squared. So 1 minus 1, positive infinity, infinity squared. So this goes to 0. 1 over a huge number is 0. So the interior goes to 1, and this part goes to infinity. So what I'm getting is 1 to the infinity. All right, one of the 3 power types. I'm going to call that L. I'm going to look at ln of L. That's to make sure I'm able to transform this power, this exponent, into a product and apply L'Hopital once I could get it to a quotient. All right, I'm going to take that x squared, pull it up in front. All right, and then this part is infinity, this part is log of 1, which is 0, so I have 0 times infinity. I need to take one of them down. I'm going to take the x squared because the log is always horrible, and we will never, never bring it down unless we're forced. All right, so x squared becomes x to the minus 2, or 1 over x squared, however you want to write it. Now this is ln of 1 over 0, so it's 0 over 0. I can apply L'Hopital. Derivative of the denominator, this is x to the minus 2. And so I'm going to do a power rule, minus 2x to the minus 3. And then derivative of log is 1 over, so I'm going to get 1 over whatever's in front. And then I'm going to take the same thing, prime it. So 1 minus 1 over x prime. This is 1 minus x to the minus 1. That's going to help me differentiate it. All right, where are we? Limit as x goes to positive infinity, 1 over 1 minus 1 over x. Then this part is x to the minus 2 because the minuses cancel. I have over minus 2x to the minus 3. All right, this and this will cancel somehow. It's always, so xa over xb, if you remember the law, it's a minus b, so it's going to be minus 2 minus minus 3. Let me write it like that. X plus infinity, I have x minus 2 minus minus 3, 1 minus 1 over x, and don't forget the minus 2. It was in the denominator, so let's leave it here. All right, so I get the limit as x goes to positive infinity. X over, oh, sorry, there's a minus somewhere else. Oh, yes, sorry, I just noticed. Well, let's keep going. If there's a mistake, I'll start again. I think it's fine. All right, so minus 2, I have minus 2, and then here I have 1 minus 1 over x. When I plug it in, I get plus infinity over minus 2 times 1. And so I get minus infinity. Remember, big positive number divided by minus 2, still big, but no longer positive, you have a negative. All right, so the limit with the log in it gives you minus infinity. And so if you want L is going to be, and I'm going to put cheating brackets because this doesn't quite make sense, but we're going to apply the same thing, but there's a limit hidden in this, e to the minus infinity. And if you remember, the graph of e looks like this. I'm going to minus infinity. That means I'm traveling this way, and the graph is going to 0, and so this is 0. All right, so I think there was a mistake in my notes. I think this is fine. I'll double check afterwards. If you're listening to me, then everything is great. Otherwise, I'll redo the video. All All right, method, indeterminate forms of type 0 to the 0, 1 to the infinity, and infinity to the 0. Here's how to solve these limit. We start by calling the limit we want to evaluate L. Then you consider log of L and use the law of logarithm. Ln of L, ln of a to the b is b ln of L. All right, so this is going to be a type 0 times infinity. You follow the method for 0 times infinity to find, here ln of L. Always bring b to the denominator. Once you have ln of L, the final step is to go back to L. Use ln of L to evaluate L. Note that L is equal to e to the ln of L. All right, so whatever value you found here, that's your final answer. All right, that's it for this chapter.